The quantum mind, unraveling the Penrose-Hameroff theory of consciousness. Imagine consciousness, the subjective feeling of being you, as more than just electrical chatter between neurons. What if it is the product of quantum events, flickering beneath the surface of our awareness, rooted in the very fabric of reality? This is the daring vision at the heart of the Penrose-Hameroff theory of orchestrated objective reduction, or OR, a hypothesis that has stirred both excitement and controversy across neuroscience and physics. The limits of the classical brain. For decades, mainstream neuroscience has mapped consciousness to the workings of billions of neurons, firing in intricate networks. In this view, our sense of self, our thoughts, and our decisions all emerge from patterns of electrical impulses and neurotransmitter releases, a biological computation playing out in wet, warm tissue. Yet for some, this explanation falls short. How does the firing of neurons give rise to the vivid, unified experience of consciousness? Why do we feel like selves, not just information processing machines? For Oxford mathematician and physicist Sir Roger Penrose, the answer must lie deeper, perhaps in the strange laws of quantum mechanics. Quantum shadows in the brain. Quantum mechanics is notorious for defying common sense. Particles can exist in multiple states at once, a phenomenon known as superposition. They can be instantaneously linked across distances in a state called entanglement. In Penrose's view, the unpredictability and non-computability of quantum events might be the missing ingredient for consciousness, something classical physics can't explain. But how could fragile quantum processes survive in the noisy, biological environment of the brain? Enter Dr. Stuart Hameroff, an anesthesiologist fascinated by the complex architecture inside our neurons. Deep within each nerve cell are microtubules, protein structures that act as both scaffolding and highways for cellular activity. Hameroff proposed that these microtubules might serve as the brain's quantum stage. Orchestrated objective reduction. The core idea. The OR theory fuses Penrose's physics with Hameroff's biology. Here's how it unfolds. Quantum computation in microtubules. Microtubules, Hameroff suggested, could support quantum superpositions, allowing them to process information in ways classical computing cannot. Objective reduction, OR. Penrose argued that quantum states don't just collapse randomly or when measured. Instead, when a quantum superposition reaches a certain threshold of mass or energy difference set by the rules of gravity, it undergoes an objective reduction, a fundamental spontaneous collapse. Orchestration by biology. The brain's structure and activity, Hameroff posited, can orchestrate these collapses, timing and shaping them in ways that correspond to conscious moments. Each orchestrated reduction is a spark of awareness, a quantum click that gives rise to experience. In this view, consciousness is a series of orchestrated quantum events woven together by the brain's biological machinery. It is not just computation, but a dance at the quantum edge of reality. The debate, science or speculation? The OR theory is as provocative as it is divisive. Critics argue that quantum coherence is too delicate to survive in the brain's warm, wet environment. Any quantum effects would decohere in a fraction of a second, long before they could influence thought. To date, there is no direct experimental evidence that microtubules perform quantum computations, much less that these are the basis of consciousness. Yet OR's supporters point to intriguing hints. Some studies suggest anesthetic gases, which erase consciousness, act on microtubules. Recent advances in quantum biology have revealed quantum effects in warm and wet systems, such as photosynthesis and bird navigation. Why this theory matters. Whether OR is ultimately proven or disproven, its impact is undeniable. It challenges us to look beyond the familiar, to contemplate consciousness as something woven into the universe's deepest laws. If even part of OR is true, consciousness would not be a mere accident of biology, but an intrinsic feature of physical reality, a phenomenon where mind and matter truly converge. The quantum mind awaits. The quest to understand consciousness is one of humanity's greatest scientific and philosophical adventures. The Penrose-Hameroff Orch-OR theory stands at its most mysterious frontier, inviting us to imagine that within each moment of awareness, there might be a quantum event, a collapse of possibility into actuality, a flicker of mind at the edge of the cosmos. In searching for answers, we are reminded that the nature of consciousness may be stranger and more wondrous than we ever imagined.